What is backpropagation's role in AI overfitting? Have you ever wondered how artificial intelligence learns from data? One of the key processes behind this learning is called backpropagation. Let's break down its role, especially when it comes to overfitting in artificial intelligence models. Backpropagation is the main algorithm that trains neural networks. It adjusts the weights of connections between neurons to minimize errors in predictions. This process involves calculating gradients of a loss function, which measures how far off the predictions are from actual outcomes. By updating these weights, backpropagation helps the model learn from its mistakes. However, there's a catch. While backpropagation is essential for improving model performance, it can also lead to overfitting if not handled correctly. Overfitting happens when a model learns the training data too well, including noise and patterns that do not apply to new, unseen data. This means the model may perform excellently on training data but poorly on fresh data. So, how does backpropagation contribute to this issue? As the algorithm continuously reduces training errors, if the model is overly complex or trained for too long without any checks, it can start memorizing the training data instead of learning to generalize. To combat overfitting during backpropagation, several strategies can be employed. One common approach is using regularization techniques. These methods, such as L1 and L2 regularization, add penalties for large weights, encouraging simpler models that can generalize better to new data. Another effective technique is dropout. This method randomly disables certain neurons during training, which prevents the model from becoming too reliant on specific pathways. This promotes a more robust learning process. Early stopping is also a useful strategy. By monitoring the model's performance on validation data, training can be halted before the model starts to overfit. Additionally, data augmentation can help by increasing the diversity of training data. This allows the model to learn more general features rather than memorizing specific examples. Finally, hyperparameter tuning is essential. Adjusting factors like learning rate and network size can help strike a balance between learning capacity and generalization ability. Backpropagation plays a vital role in training advanced artificial intelligence models like ChatGPT, DALL-E, and Midjourney. These models utilize deep neural networks and incorporate techniques to manage overfitting during training. This ensures they maintain high performance on new inputs while learning complex patterns from large datasets. In essence, backpropagation is the driving force behind learning in neural networks. It adjusts weights to reduce error, but without proper management, it can lead to overfitting. By applying regularization, dropout, early stopping, and careful tuning, artificial intelligence models can achieve a balance between fitting training data and generalizing to new data. This balance is essential for effective and ethical applications of artificial intelligence.